In this video, I'm going to go over two problems from the AP Calc Bible. They are both on page 14. The first one is example 4. It's telling us that a crate that it's open at the top has vertical sides, a square bottom, and a volume of 500 cubic feet. So it's open at the top, square on the bottom, and the volume. We want to figure out the minimum surface area. So if you think about surface area, you want to think if you would paint this. Okay, if you would paint it, you have a bottom, you don't have the top, and then you have 4 sides. So since the base is a square, I'm going to call the dimensions x. I want to let them know what my dimensions are, so I'm going to write x and x. And then the area of that bottom would be x squared. I'm not going to include the top because it's open. And then 4 sides of dimension x times the height. I let the height be y. So I have surface area is x squared plus 4xy. Now when we do an optimization problem, we want to get it in terms of one variable. So I'm going to use that piece where the volume is 500 cubic feet. Volume is 500. Volume is length times width times height. In this case would be x times y. Then I'm going to solve it for y. It was very easy for me to figure out that y was going to be the easier one to solve it for. And when I plug it back in, it would have been much more difficult to substitute in for x because there's an x squared and an x. So instead, I'm going to let y equal 500 over x squared, simplify it to get my surface area formula, take the derivative to find my critical numbers, which is where the derivative is 0 or undefined. 0 wouldn't make any sense because then we wouldn't have an open top box. You'll get 10. We truly want to check to see if it is a maximum because remember, critical numbers aren't necessarily relative maxes or mins. We have to check to see if the derivative changes from negative to positive here. So it does. So 10 feet was x. I can go back and substitute and find out what y is. I can get the dimensions and then I can get that minimum surface area. The next question is number 5. This one is a rectangle inscribed in a semicircle. They want us to be able to figure out that this is the top of a circle. If we went through and solved it, it's x squared plus y squared equals 18. That kind of got cut off the page. So I know the radius is the square root of 18, which is a little bit more than 4. So I'm going to center this rectangle over 0, 0. I'm going to go out root 18 on either side. And they want us to find the length and the width where the rectangle would be a max. So I like to set mine up this way because then I just use x as my typical x coordinate for a point in that first quadrant and y being the typical y coordinate. But the rectangle would then be 2x times y. So my area formula for that rectangle. Then I'm going to use the y equals the square root of 18 minus x squared to get my area formula. Now this derivative is a little tricky. They've given us problems like this where we had to take the derivative many, many times because we tend to forget, first, it's the product rule. Second, there's a chain. So v u prime plus u v prime, which was 1/2 u to the negative 1/2 times u prime. I'm going to simplify it, get it to be a nice fraction because then it's easier for me to find all the critical numbers. There are 4. Negatives aren't going to make any sense here because I'm trying to find out what that x is in the first quadrant and then I can figure out the area. Root 18 doesn't make sense because that's beyond what x could be. That was the radius of the semicircle. So the only feasible solution would be x is 3. I do have to check to see if the derivative changes from positive to negative. It does, so it is a maximum. So then I can go and find my dimensions. If x is 3, I can find y, and then I can find the maximum area. They didn't give units on this one, so we could put